Hello and welcome to this video on proportionality or the ratio relationship between speed, time and distance when one out of these three parameters is given as constant. This and the next two videos are very important. We have distance is equal to speed into time, and let's say there are two scenarios in which speed is same constant value. We have speed as constant. That means distance is constant times t. Distance is directly proportional to time. So if there are two cases, one in which distance d1 is covered in time t1, and second case distance d2 is covered in time t2, and in both the cases speed is s only. Then we can say distance is directly proportional to time. That means d1 upon d2 is equal to t1 upon t2. If ratio of distance covered in both the cases is 2 upon 3, d1 upon d2 is 2 upon 3, then t1 upon t2 will also be 2 upon 3. If d1 is 2 and d2 is 3, that doesn't mean t1 is 2 and t2 is 3. That will mean t1 upon t2 is 2 upon 3. Now this is the case when speed is constant. Now if in two scenarios we have time as constant, then distance will be equal to constant times speed. Okay, that means distance is directly proportional to speed. So let's say a boy covers d1 distance with s1 speed in t time and d2 distance at s2 speed in again t time. Time is constant in both the scenarios. That simply means d1 upon d2 will be equal to s1 upon s2. Okay, if d1 upon d2 is a by b, s1 upon s2 will also be equal to a by b. Third case is when distance is constant. We have distance as constant. That means speed will be equal to constant upon time. Speed is inversely proportional to time. That means s1 upon s2 will be equal to t2 upon t1. Okay, how else can we see it? We have two scenarios in which distance is constant. Speed s1, time is t1 and distance is d. Speed is s2, time is t2, distance is again d. So distance in both the scenarios is constant. Distance in first case is s1 into t1. Distance in second case is s2 into t2. Both the distances are equal. So from here we can get s1 upon s2 is equal to t2 upon t1. Let's take these cases and solve a few questions based on these. Suraj travels a certain distance in fixed time. If he travels 3 by 2 times more, he takes 1 hour more. Okay. All it says is that more distance can be traveled in more time. It doesn't say anything about speed. See, this is the first scenario when certain distance is traveled in fixed time. Okay. And this is the second scenario when more distance is traveled in more time. So distance and time has changed. The speed we will have to assume to be constant. Speed is constant. We will have to assume speed as constant, because if speed has increased, then of course more distance could be traveled, like in the same time only. But here time is also increasing and distance is also increasing. That means with same speed he is traveling more distance in more time. We will have to assume speed as constant in such questions. So speed is constant, distance will be directly proportional to time. So if new distance is becoming 3 by 2 times old distance, then new time will also become 3 by 2 times old time, because time is directly proportional to distance. Now this means t old plus t old upon 2. This means an increment of half over 1, right? And this increment is given as 1 hour. He takes 1 hour more than the old time. So this old time plus old time upon 2, this increment is equal to 1 hour. So t old upon 2 is 1 hour. That simply means that t old will be equal to 2 hours. This is the actual time taken to cover the distance. Give this question a try and then proceed. If a person walks at 14 km per hour instead of 10 km per hour, so the speed has increased. Okay, from 10 km per hour, it has become 14 km per hour. He would have walked 20 km more. So due to increase in speed, he is able to walk 20 km more. Emphasis here is on increase of speed, which enables the person to walk 20 km more in the same time. Okay, this is not given in the question that time is same in both the cases, but you will have to infer that time is being constant here because he is able to walk more due to increase in speed and not due to increase in time. Time we have to assume as constant. See, of course, he is going to travel more distance in more time, but here the reason for more distance travel is given as increase in speed. So we can surely and safely assume that time is constant. Also, if time was also to vary, then the question was unsolvable. They have also given speeds of the two scenarios. Okay, we have 10 km per hour and 14 km per hour. This is extra information. All we needed was ratio of old and new speed or percentage change in speed. Here we have increment of 40%, right? From 10 to 14 there is an increase of 40%. Now as time is constant, distance will be directly proportional to speed, so there will be a 40% increment in distance as well. A 40% increase in speed means a 40% increase in distance as well. So from d old to d new there is an increase of 40%. And this increment is equal to 20 kilometer as he walked 20 kilometer more. So 40% is equal to 40% corresponds to 20 kilometer. What will 100% correspond to? That will be 20 upon 40 into 100, which is equal to 50 kilometer. Okay, this is the actual distance d old. Okay, last example for this video. Read the question, give it a try. We have taken cases where speed was constant, time was constant. Now we have a case where distance is constant. Walking at 3/4 of his usual speed, a person is 10 minutes late. Now this is second scenario. The first scenario is when he walks at his usual speed and he reaches on time. Okay, he has a usual speed fixed with which he reaches on time to his office, which is at a fixed distance from his home. But then he changes his speed and time also changes, but distance from his home to office is going to be fixed only, right? Distance is constant here. Only reason why he is taking 10 minutes more is not because distance has increased. This 10 minutes more that he is taking is because his speed has decreased. So we have distance as constant here, distance as constant. That means speed will be inversely proportional to time. Okay, and we have in the question new speed as 3/4 times old speed, right? That simply means 3/4 times old speed. That simply means a decrease of 25%, right? 3/4 is 1 minus 1/4, a decrease of 25%. So speed decreases by 25% and speed and time are inversely proportional. Can we say time increases? Can we say time increases by 25%? Well, saying this will be wrong. This logic is wrong, as we have seen in percentage video that to cancel out increase of 25%, you have to decrease by 20. Or after decrease of 25% to get original value, we used to increase by 33.33%. Okay, you take a value x, you increase it by 20%, you get y, you decrease y by 20%, you won't get x again. I hope this is clear to you from the percentages video. Okay, so I'm moving forward considering this point is clear to you. Okay, we have new speed as 3/4 times the previous speed, and the ratio is inverse. Speed and time are inversely proportional, so we can say new time will be 4 by 3 times the older time, the earlier time. Okay, that simply means this factor of 4 by 3 simply means 1 plus 1 by 3, right? And this 1 by 3 increase on the original time is given to us as 10 minutes increase, right? So 1 by 3 increment is equal to 10 minutes increment. 1 by 3 is equal to 10 minutes, or we can say this is t old plus t old by 3. This t old by 3 part is equal to 10 minutes. That simply means the earlier time, the previous time, will be equal to 30 minutes. The time that he usually takes to reach office is 30 minutes. I hope with this video I was able to explain the proportionality between speed, time and distance when one out of these three parameters is given to you as equal in two cases.